Okay, in this video we're going to talk about a review of trigonometry. We're not going to use a whole lot of trigonometry in this course, but it is important that you understand some of these basics. So we're mainly going to be working with right triangles. A right triangle, of course, is one that has a 90-degree angle. Whoops. Okay. So before we can start talking about doing any math with this, we need to define some parts of this triangle. So the side of the triangle that faces opposite of the 90-degree angle is called the hypotenuse, or H. A lot of times we use a capital H instead of lowercase h, both to represent the hypotenuse. The side that then we need to decide which angle is known, or which angle are we interested in working with. So in this diagram, the angle that we're interested in is marked here as theta. So if this is our theta, then the side that is opposite of that, across from it, is called the opposite side. And here they have used H sub O, meaning height opposite. Now, we're not always going to be working with heights, so often we just call this O instead of H sub O, because this might represent other quantities. And then this side is called the adjacent side. So if you look at your angle that's labeled as theta, you'll see that the angle actually touches two sides of the triangle. And then the opposite one is the one that it does not touch. So this side is adjacent to the angle, and this side is also adjacent. Adjacent just means next to. Since this one is already designated as the hypotenuse, we'd call this side the adjacent side. Again, this HA meaning height adjacent, but a lot of times we just use A instead, so we'll do that. Alright, so once you have these labeled, now we can talk about using some math equations. So one thing that you can remember that's fairly easy to remember is this little saying: so, ka, toa. Okay, so this is just a little device for helping you to remember the trigonometric equations associated with the right triangle. So the first letter in each of these stands for a trigonometric function. So S stands for sine, C stands for cosine, and T stands for tangent. Now sine, cosine, and tangent are all operations that you perform on an angle. So this would be sine of the angle theta. That's the angle that we're interested in, that we've chosen to use for this triangle. So this would be cosine of theta and tangent of theta. Okay, then the second two letters stand for two of the sides. Notice they're all O's, A's, or H's. So after the trigonometric function, we write an equal sign, and then the second letter goes on top, and the third letter goes on the bottom. So this means if you take the sine of the angle theta, it will give you a number that's equal to the opposite side divided by the hypotenuse. Okay, same for these work the same way. So cosine theta is equal to A over H, adjacent over hypotenuse. So if we take this side divided by this side, we'll get a number that's the same as if we take the cosine of this angle. For tangent, we have OA, so that gives us opposite divided by adjacent. So these three equations are useful if you know one of the sides and the angle, and you want to find out the other side. Or if you know two sides and you're looking for the angle and you want to solve for the angle theta. So either of those situations is where you want to use these equations. So let's look at an example. Here we have a building. So the sun is shining on the top of the building, and sunbeams travel in a straight line. So here where the sun ray hits the ground over here, this is going to be where the end of the shadow is that's being created by this building. So we can easily measure along this line the length of the shadow. That's going to be a little easier to measure than trying to measure the height of the building. So if we want to know the height of the building, we can use a little bit of trigonometry. We can figure out that this angle is 50 degrees by measuring, and we can measure this length, and we can calculate the height. So before we go any further, let's label the sides of our triangle. This one's already labeled as our angle theta. So we know this is our angle of interest. And the right angle, of course, would be here. So our hypotenuse is going to be across from the right angle. This would be our adjacent side because it is touching the angle. It's one of the sides that make up this 50-degree angle. And then this side over here would be our opposite side. Okay, so what do we know? Writing down our knowns, we know theta equals 50.0 degrees, and we know that the adjacent side equals 67.2 meters because we could measure those things. What do we want to know? We want to know what is the opposite side. How high is that, this side here? So we don't care about the hypotenuse for this problem. We don't need to know that. We don't know it, but we don't need to know it either. So we need one of our equations from the previous slide that has theta, A, and O in it. So two of the things that we know and the one thing we don't know that we want to know. So going back, which one would that be? Here we are, theta, A, and O. So we need to use the tangent function. As you see, sine and cosine both have the hypotenuse in it, which we don't know and we don't need to know. So we're going to go with tangent. So tangent TOA. So that means tangent of the angle theta is equal to the opposite side divided by the adjacent side. So before we plug any numbers in, we're going to rearrange this to solve for our unknown. And this is a good skill to get used to doing because often on the AP exams especially, they're going to ask you to rearrange an equation and you may not even have numbers. So we want to solve for O. That was our unknown. So we simply multiply both sides by A. So it cancels out from here. And then we see that O is equal to A times tangent theta. So we're going to flip these around because we usually write our unknown on the left-hand side. Alright, so if we then plug in our numbers, we have O equals A, which was 67.2 meters, times tangent of 50.0 degrees. If you work that out in your calculator, you should get 80 meters. Okay, and then the last step, does this make sense? So since this was a 50-degree angle here, we would expect this side to be longer than this side, which it worked out to be. So it's close, it's on the same scale, but it's longer. So this makes sense. Let's try one now where we know two sides, but we're looking for the angle. So here we have a fisherman that's going out in a boat on a lake that has a very, very, very evenly sloping bottom. We're not going to use this number for this problem. We're just going to use this 14. So he's gone out 14 meters into the lake, and he measures the depth with his fish finder here, and it's 2.25 meters. So the triangle that we're using here is really this one, the one that goes along the surface of the water, and then straight down, and then along the base of the lake. Our theta then is this angle here. So our right angle would be here. If we have a level horizontal surface for the water and we drop straight down, that makes a 90-degree angle. So that would make this our hypotenuse because it's across. If we're looking for this angle theta, then this side would be the adjacent side, and this side would be the opposite side. So here we have adjacent and we have opposite, and our unknown is theta. So again, we don't know the hypotenuse, and we don't need to know it for this problem either. So we're going to use the same equation we used before, the tangent one, TOA. So that's tangent theta equals opposite over adjacent. This time we're solving for theta. So to get theta by itself, we have to do the inverse of whatever is currently being done to it. So in this case, that would be the inverse tangent function, tan to the -1. And on most calculators, that's just the second function on the tangent button. Okay, so if we take inverse tangent of theta, that cancels those two out and leaves us just with theta. So theta equals the inverse tangent of the opposite side divided by adjacent side. So now we've got our unknown by itself, and everything over here are things that we know that we can plug in. So theta equals inverse tangent of 2.25 meters divided by 14.0 meters. And if you punch that into your calculator, that works out to be about 9.13 degrees. Make sure your calculator is in degree mode, not radian mode. Otherwise, it's going to give you the number of radians that equals instead of the number of degrees. We're mostly going to be using degrees in this course. Okay, and then the last thing that you really need to remember from trigonometry is the Pythagorean Theorem, which you probably learned a long time ago. So most often you see this as a squared plus b squared equals c squared, where a and b stand for the two legs. We'll call this a and b, and c is the hypotenuse. So this is what we were calling h before. This was our opposite side, and this was our adjacent side. So if you wanted, you could still call this a for adjacent, o for opposite, and h for hypotenuse. In that case, this would read a squared plus o squared equals h squared. So whatever symbols you want to use, it works out to be the same equation. So this is useful if you don't care about the angle or don't know the angle and all you're worried about are the three sides. So if you know any two sides of the triangle, you can use the Pythagorean theorem to figure out the third one. Alright, that's it for section 4. We'll do some more practice problems in class.